Well, dear students, in the last video, I started about the equation of progressive wave, and I told you about phase and many things now, but I repeat. Actually, just before this period, I was teaching students of class 11 who were not able to tell me what is the meaning of this equation. Or we can write this as y equal to a sine omega t, y equal to a sine 2 pi t upon t minus x upon lambda. This equation, these are the same thing. So I told you that this is an equation of progressive wave. And what is y? What is t, what is x, what is lambda, what is capital T? I had to keep mum for long time, and they were not spell out what is the meaning of this y, what is telling to you. So I am repeating you y. This is a question of longitudinal or any progressive wave traveling in positive x direction. Here, I told you when wave travels through medium, particles of medium oscillate about their mean position. They don't leave the mean position. They keep on oscillating about mean position. I drew the diagram there were particles like this, and they were shown oscillating. This displacement 0, this much, and then less than 0 and this direction. And this displacement I have shown like this. तो ये displacement इसका है, इसका ये negative है, इसका 0 anyway. तो why it is called equation of wave? Because this equation tells us the displacement of particle of medium at distance x from origin at time t equal to t. At time t, at distance x from origin, y is the displacement. Here a is the amplitude of wave, t is the time period, lambda is the wavelength. It is plane progressive, means everywhere a, t, lambda same. Only variable thing are time t and distance x. So by knowing this from this equation, we can tell displacement of any particle at time t at distance x. If we put here x equal to 0, we get only y equal to a sine omega t, and that is, it means y is the displacement at origin at time t. We have learned in SHM. So please think over it, what we are doing, what is the message, and why it is called equation of progressive wave. I told you phase. Y equal to a sine omega t minus kx कह लीजिए, और y equal to a sine 2 pi upon t 2 pi t upon t minus x upon lambda. So these are the equations. Same. These are the these two represent same equation. Whose represents omega, time period t, wavelength lambda, wave number k. And this whole thing is called phase. Just to make you understand what is phase. Actually, I have two functions. Suppose y equal to a sine omega t, other y dash equal to a sine omega t plus pi by 2. What is the difference? Here difference is 90 degrees. What does it mean? Means at t equal to 0, y is 0. At t equal to 0, y dash is a. Y dash is a. It means if I take the reference circle at t equal to 0, y0 the body moving oscillating is here, and at this time y dash is here at t equal to 0. Means its displacement 0 from in position it's capital A, and this represents phase difference of pi by 2. And at t equal to 0, y dash ahead of A. At t equal to 0, y dash equal to A, y equal to 0. तो y dash पहले से आगे गया हुआ है, तो we say that it leads, y dash leads y in phase by pi by 2. Like that. This is also very important to understand. Now, if we have another wave which has a phase difference of pi, so that y dash will be a sine omega t minus kx or plus or minus phi. Here phi is called initial phase. If there is plus phi, it means it is y dash leads y in phase by pi. Here pi may be called an initial phase. Some people may write it like this also, y double dash a sine omega t minus kx plus minus phi. उड़ा लिखते हैं. We will discuss it later while telling you progressive or stationary wave. So this was all about again repetition or revision of equation of simple harmonic progressive wave. Now, two things are missing from this book of NCERT here, which are very important. Actually, they have not been mentioned in syllabus. Teachers, for their ease of time, so that they can finish the syllabus in small time, they say this is not in syllabus, so there is no need. But this is needed. There is one topic, wavefront. What is wavefront? So when wave travel through medium, particle of medium oscillate. And at different point, there may be different phase, or some particle may be oscillating in same phase. So scientifically, I will explain the meaning also. The locus of points oscillating in same phase is called wavefront. Is called wavefront. Locus of points oscillating in the same phase is called wavefront. Now I may give the example here. If this is some container of water, suppose it is trough of water. Here water is filled, and by using a rod, you dip the rod here again and again, so here circular ripples are formed. Circular ripples are formed. These circular ripples, on the circular ripples, all particles either coming out or going down, or moving this way or this way. So these circular ripples are their wave fronts. I think you have got my point. When we create circular ripples on the surface of water, which is at rest, you take bucket of water or trough of water at home, dip the rod again and again, so circular ripples are produced. This is one wavefront, this is another wavefront, this is another wavefront. On this wavefront, all particles will be oscillating in same phase. So the locus of point oscillating in same phase is called wavefront. Don't get afraid of this. Actually, I had been a student also, and still I am a student, learning every time the same subject. Keep on learning again and again, again and again. But I feel when I read, sometimes I get sleepy, sometimes I don't understand, and feel how much have to be read. तो उससे मत डरिए आप. The locus of point oscillating in same phase is called wavefront. For a point source, wavefronts are spherical. I am source here producing sound wave. They spread in all direction. So spherically. Figure भी so plane ना wavefront on plane surface of water circular दिखते थे वो. Spherical and for linear source. Wavefront are cylindrical. The normals to wavefront are called rays. Now, what is the meaning of ray here? This ray, the ray at any point gives the direction of propagation. Direction of propagation of wave. Like this I can show by diagram. If it is point source here and I show this part of wavefront, then ray to this. Here wave is supposed to go this way. Here wave is supposed to go this way. This is wavefront, say मान AB is the plane wavefront. Now for cylindrical source, this is the source of wave. For cylindrical line source, so all like this cylindrical. And normal to this will be this. This is the wavefront, cylindrical wavefront, all around. So at large distance, from the sources, from the source, a small part of a wavefront is treated as plane wavefront. Actually, this is necessary to understand in class 12 or everywhere we understand wave, and we tell wave is the periodic variation of physical quantity which transfer energy. Light waves are reaching our different parts of the room, and at different parts light is not equally illuminating. The farther the distance, smaller become the intensity, energy falling. To understand how much is the amplitude of vibration, by I told you y equal to a sin omega t लिखा हमने, या पूरा लिख लें माइनस के एक्स भी कर दें. तो हाउ मच इज द एम्पलीट्यूड ऑफ साउंड वेव, किसी वेव का एम्पलीट्यूड क्या होगा, दैट विल बी अंडरस्टूड बाय नोइंग ऑल दीज थिंग्स distance wise. There are different terms. Now I will come to the term intensity of wave. Actually the video has been 16 minutes. Or wave front, I hope you have got my point. So energy of source is a source. It will be spreading all around. So how much intensity is there? This energy, total energy, is spreading in the sphere. If we think this is a wavefront, this is not a part, it is spherical here. The total energy produced here gets distributed over the whole wavefront. So if it is source of milliwatt, light sources generally are of certain milliwatt, not of kilowatt, not of these speakers used in Jagan and somewhere music system, they are having large amplitude, they are having large in power, which is not useful, that is harmful for us, but people are not understanding. All are doing something wrong which they don't know. I can't give any statement here because people are in other way also here. Science people are, who have understood science, he behave like other way, and who do not understand, not read. Understanding is the factor. So this was about wavefront. I repeated here again the wave and the phase. So on a wavefront, देखो अभी हमने एक्सप्रेशन डेवलप किया था डेल्टा फाई इक्वल टू 2 पाई अपॉन लैम्बडा इनटू डेल्टा एक्स. This is a wavefront here. All particles here are in same phase, whether this one or this one, this one or this one. There was question in board exam ke a wave is produced in medium of wavelength 1 meter. What is the phase difference between 2 points on a wavelength which are several distance of 2 meter? तो बच्चों ने 2 रख दिया 1 मीटर के 4 पाई. Wavefront, on wavefront, all particles oscillate in same phase. By definition, they did not use the definition, they use this formula. This formula lies only when we are at different distance. एक wavefront यहाँ से यहाँ होता है यहाँ से, तो उनके बीच में हो सकता है. But on same wavefront, all particles oscillate in same phase. Please remember it, and please like the video, share the video, and please, if you have not subscribed my channel, subscribe the channel. It encourages me to do some work for you, though I have nearly completed class 11 syllabus. So please like the videos also.